In this video, the learning target we're going to look at is I can solve application problems by writing quadratic functions and factoring to find the solutions. So number one says you make a rectangular quilt that is 5 feet by 4 feet and you use the remaining 10 square feet of fabric to add a border of uniform width to the quilt. We want to figure out what the width of the border is. So over here there's kind of a diagram of the situation. We have a quilt. It said that it's 5 feet, so this distance here, okay, let's say that's the height, so to speak, or I guess the width is 5 feet. So both sides will be 5 feet. And then this length they're saying is 4 feet. Okay, so we've made this quilt 5 feet by 4 feet. And then we're adding a border around it some length. So you'll notice that's marked with an X for just some general width of a border that we're going to put around this thing. Okay, and we're going to do that with the 10 square feet remaining of fabric. So to do this, I know that the area of the border has to be made out of my 10 square feet of fabric. So the area of the border has to equal 10 feet squared. Okay. Then what I can do is I can figure out what the area is algebraically. So notice this first piece. Okay, if I consider this rectangle right here, if I find the area of that guy, well, it's got a height of 5 and a base of x, right? So this rectangle's area would be 5x. The one across from it, same thing, height of 5, width of x. So this one's area would be 5x as well. Okay, so both of these areas are going to be 5x. The ones on top and bottom, those are both going to be 4x. Okay, the reason why, we have a width of x and we have a length of 4. We have a length of 4 and a width of x. Okay, so those 4 areas consist of these 4 rectangles. Okay, but hopefully you notice we're missing the 4 corners. Okay, so when I look at this diagram, I haven't figured out the area of these 4 corners, and I need to know what their areas are as well. So if I look at one corner, you'll notice that the height is x tall and it's x wide. So the area of this guy is x times x, or it is x squared. Okay, so x squared is the area of this corner. Now, all 4 corners are going to be the same. So each of these, their area is just going to be simply x squared. Okay, so right now, all I'm doing here is I'm just listing off algebraically what the pieces' areas are. So each corner is an x squared. We have a 5x and a 5x, a 4x and a 4x. And when we add up all those areas algebraically, they should equal our total of 10 square feet. So if I do that, if I take x squared plus x squared plus x squared plus x squared, if I add the 4 corners, that should be 4x squared. Then if I add the rectangles, well, I have 4x plus 5x, that's 9, 13, and 18, so I get 18x. And then, like I said, when I add up all those pieces, that should equal my total of 10 square feet. Now, you'll notice this is a quadratic in standard form, so I'm going to get everything on one side. I'm going to minus 10 over. That gives me 4x squared plus 18x minus 10 equals 0. And then I can solve this guy by factoring. Now, once again, when we factor, we ask ourselves what times what gives us our first term, but you'll notice 4x can break apart multiple ways. I could break this into 4x and x. I could also break this into 2x and 2x. Okay, so there's kind of 2 different ways I can break apart this first number. And then when I look at the last number, what numbers give me the last? Well, that's 1 times 10 or 2 times 5. Now, I'm looking at these numbers trying to figure out how I can get to 18. And I notice that if I use this second pair, 5 times 4 gets me to 20. And then if I take 2 away from it, that'll give me 18. So I'm going to put 5 in the last spot, so that gives me 20x. and then I'm going to put 2 in the inside, so that gives me 2x. To get 18 as a positive number, I need the 5 to be positive and the 2 to be negative. Okay, so this is the correct factoring. Then, if I know each factor being multiplied together equals 0, well, I just set both factors equal to 0. So either 4x minus 2 equals 0, or x plus 5 equals 0. So I'm going to get x equals negative 5, and I'm going to get 4x equals 2, so x must equal 2 over 4, which reduces to be 1/2. Okay, now when you look at these two answers, we're trying to find what is the width of the border. Well, one of our answers is negative, one of our answers is positive. So the width is going to have to be a positive answer. It can't be negative, so we're not going to use this guy. So we would say that the width of the border is going to be 1/2 of a foot. Okay, so this x value on our quilt is going to be 1/2 of a foot all the way around. That's going to be the width of the border. All right, let's go ahead and look at a second word problem here. So number 2 says a quadrilateral is divided into 2 right triangles as shown in the figure. So you have a right triangle on top, right triangle on the bottom. It wants to know what is the length of each side of the quadrilateral. So it wants to know what these 4 side lengths are. Now, what we're going to do is we're just going to think of one triangle at a time. So imagine that you just cover up this bottom guy. Okay, and when you have a right triangle, remember that a squared plus b squared has to give you c squared, your hypotenuse, right? So I know that if I take 6x squared plus 8x squared has to equal c squared. Okay, when I square the sides and add them, I have to get c squared in the middle. Okay. Now, similarly, if I cover up the top guy, okay, I have a right triangle on the bottom, so same thing. 5x squared plus 300 squared has to give me c squared. So the second guy will be 5x squared plus 300 squared has to give me c squared. Now, hopefully you notice that both of these equal c squared. So because this side equals c squared and this side equals c squared, we can actually set these two equal to each other. So we get 6x squared plus 8x squared equals 5x squared and 300 squared. And then we just go ahead and start simplifying this guy. So if I square 6x, so 6x times 6x, well, 6 times 6 is 36, and x times x is x squared. 8 times 8 is 64, x times x is x squared. 5 times 5 is 25, x times x is x squared. And then if I take 300 times 300, I get 90,000. And then I want to get all the x's onto one side, so I'm going to minus 25x squared from both sides. I get 90,000 equals 36x squared plus 64x squared minus 25. Well, 36 plus 64, that's 100. And then if I subtract 25, that's going to give me 75x squared. And then if I want to solve this, I want to get the x squared by itself, so I'm going to divide by 75. I'll get x squared equals, and then using my calculator here, I'm going to take 90,000 divided by 75, which gives me 1,200. And then my last step here is to take the square root of both sides. So if I take the square root of 1,200, I get 34.64 as my x value. Now remember, this question is asking us what is the length of each side of the quadrilateral. Right now, we just have x is 34.64. We need to plug x in to find what these sides actually are. So I want to take that number times 5, which would give me 173.2. Then I want to take 34.64 times 6, which is going to give me 207.84. And then lastly, I want to take 34.64 times 8, and that gives me 277.12. And then once again, these are all in feet, so these would all be feet. Okay, those are the side lengths of the quadrilateral.